In this class, we're going to take a look at how you differentiate sine and cosine functions. And to be honest, it's a fairly easy process. You just need to learn a couple of formulas, I guess. So in general, if you've got a sine function of the form, not just sine x, but sine ax to compensate for potentially having some number in here like sine 3x, sine 4x, or even a negative number or a fraction, but something in that format. When you differentiate that, you get a cos ax. So a couple of features there, right? So sine becomes cos, positive cos, okay, that's one thing. This part stays the same, and this number comes in front, but a little qualification on that. That number is not just coming in front because you take the number in front. A is the derivative of ax. So whatever the derivative of this function inside the bracket is, that's what you put in front. So for example, if this becomes a more complex function, then this would be more complex. We're going to take a look at a few examples of this in a moment. So that's basically the derivative of sine. Conversely, the derivative of cosine flips over to negative sine. So the derivative of cos ax, you also pull the a in front for the same reason. The derivative of ax is a. So you would get, oops, sorry, I've not left enough space there. So we get negative a sine ax. So you just need to learn these rules. They're fairly simple. Sine goes to cos, cos goes to negative sine. That's a pretty good way to remember it. So let's just start to work up a few examples. So we'll just start with something fairly straightforward. So if your function was cos, say 3x, all you're going to do there is say, right, well, cos becomes negative sine. So my derivative becomes negative 3 sine 3x. That's all you have to do. Let's take a look at another one. So let's say we've got a sine function. Sine, let's say we've got minus 2x, like that. Then just the same process again, the derivative of minus 2x is minus 2. What we're actually doing here is using the chain rule, because we've got a function inside of another function. If you're not familiar with the chain rule, it's basically a rule for differentiating composite functions. This is a composite function. This is in the format of a composite because that's a function there, ax. Sine is a function, so you've got a function inside another function. That's when you've got to use the chain rule. And so what we're actually doing here is using the chain rule kind of approach. The chain rule requires the derivative of the internal function and the external function. So don't really need to worry about that too much. You just need to worry about using the rule. So the minus 2 is the derivative of minus 2x. That comes in front. Sine differentiates to positive cos. So you get minus 2 cos minus 2x. It's very tempting with the minuses to make that into a positive. For some reason, I'm not sure why, but the bracketed part never really changes. In fact, it never does change. It doesn't not ever really change, it never changes. So that bracket is always going to stay the same. Okay, so those would be kind of standard examples. Let's look at something maybe a little different, a little more complex. So let's say that our g of x function was something like, in fact, let's work one more like this and then we'll look at a more complex one. So let's say our g of x is 3 cos 2x, like that guy there. Then our derivative, multiplying the derivative of the inside of the bracket, the 2x, in front, the derivative is 2, but it's going to combine with a 3, 2 times 3 to make a 6. We need a negative because it's a cosine, negative 6 sine, and then the bracket doesn't change to 2x. Okay, so that is the derivative of that guy there. Okay, so finally, maybe a slightly more complex version. So we'll go for an h function this time, just to mix it up a little. So let's say that we've got, let's go for a sine, and the inside will be x cubed. So sine of x cubed. It's not unusual in this topic to see functions in this format. And basically what we would be testing there is that you know not to just replicate this by pulling this value a in front every time, but that you know that the a comes in front because a is a derivative of the inside of the bracket. Usually it's just a number and we just pull the number in front, but if you keep just doing it like that, you forget maybe that you're using a derivative. This time it's a little more complicated, so we need to think, right, how does the process differ? So our derivative h dash x, the derivative of x cubed is 3x squared. So we take that derivative and put that in front. So 3x squared comes in front. Sine changes, differentiates to cosine. The bracket doesn't change, so we get 3x squared cos x cubed, which would be some crazy function. These are more popular where you've got it in the format sine, cos, number, x, but you will see variations. So these are the ones that students tend to get tripped up on. So definitely try a few practice questions on this topic and try and find some examples which are a little more elaborate. Once you've worked those examples, going back to the easier ones will just make them easy. They'll make them fairly trivial. Try and get a bit of a variety, because on tests and on exams, they do tend to mix these up a little. Just to test, you really know how to get from there to there. So that's how you differentiate sine and cosine.